Hello, let's continue our Sudoku adventure with Visgraat by rockratzero. So we have irregular 6x6 Sudoku rules. That means in every row, every column, and every bold outlined region, we're placing the digits 1 to 6 exactly once each. So instead of our normal 2x3 boxes, instead we have these 6 bold outline regions. They're still of size 6, and there's still 6 of them. They're just weird shapes. Some people call this a jigsaw also. We also have killer cages in the grid. So digits in a cage sum to the value in the top left corner. So for example, these 3 cells would sum to 10. These 3 cells would sum to 14. And digits can't repeat in a cage, although I don't know that that is relevant here. Now what's going on with this region actually? I'm assuming it's this. This is quite irregular, but I think this here, get a good color. These green cells are a single region. So it's kind of going diagonally. That's very irregular even for an irregular, but do keep that in mind that does appear to be a region. All right, well, those are the rules. There is a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, so I think one property we're going to want to use, I guess there's some low-hanging fruit here, but one property we want to use is that the sum of a region, sum of a row, column, and region, right? It's going to have 1 to 6 exactly once each. So the sum is going to be 21, because 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. We can use that for what's called outies. Now, first of all, we do have the 6 here, so a 6 cage can only be 1, 2, 3. If we're not allowed to repeat digits, got to be 1 plus 2 plus 3. It's the smallest 3 digits you can put in there, and they add to 6. That does mean that this is 4, 5, 6. It also means there's a 3 in one of these two, because this 3 says not here. So where does 3 go in this region, maybe? Yeah, that's useful. So 3 is taken out of these 2 cells by this given, and then these 3s point up, taking it out of these 2. So this region needs a 3. It's going to be in one of these 2, but it actually can't be here either. So 3 is placed in this region. This region's going to need a 3. It's going to be up here somewhere. Not here, obviously. One of these 2 is a 3. Now, if this was a 3, could we add to 10? Yeah, these 2 would just add to 7 in some way. 1, 6, or 2, 5. Okay, so let's think about these 2 outies here for this region. So, and actually, even if it wasn't a region, if we just had these 5 regions, if you think about it, if I take them all together, right, these 5 regions, oops, not those. These 5 good regions here, the ones that don't do weird things, the purple cells, that would be 5 sets of the digits 1 to 6. And so the leftovers here would still be a set of 1 to 6, non-repeating, because all the other ones are accounted for. So maybe that's what Rockrat was going for here. But you can also just think of this as a region from the start. But anyway, this region, we know these add to 9 without a 3. So we can't, see, if we didn't use a 1, we'd have to be 2, 3, 4. And that doesn't work because that uses the 3. So we do need to use a 1, and then we need 2 digits adding to 8. And that's going to require 2, 6, because we can't do 3, 5, or 4, 4, right? So we're going to be 1, 2, 6 for our 9 cage. And that leaves just the 4 and the 5 left. We could have also thought about how 9 plus 3 is 12, and to get to 21, we need another 9, and we can't do 3, 6, so we have to do 4, 5. It works out the same. Luckily, it works out the same. Otherwise, that means the logic broke. Okay, do we have anything about 3s in here? Actually, we have something going on here. So these 2 rows have 2 1s and 2 2s between them, like 1 each, right? 1, 1, and 1, 2 in this row, 1, 1, and 1, 2 in this row. So these 2 rows have 2 1s and 2 2s. But these 2 cages also have 2 1s and 2 2s. So that means that we can't put another 1 or 2 over here. And in fact, what was I going to say? Oh, I was thinking about 3s, but I think 3 is okay. So these just aren't 1, 2. So these are from 3, 4, 5, 6. I'm just going to write that out. Might as well. And actually, we do have a 4, 5, 6 triple here now. Oh, actually, there's something we could have thought about here. We're getting the same thing no matter what, but something interesting to think about here, just to point it out, is that we knew we needed 2 1s and 2 2s in these cells. And so these have to be a 1 or one of these is 1, one of these is 2. Because we can't put 2 1s and 2 2s just in this row, right? So think about 1s on their own, right? I need 2 1s in these green cells. Well, I can only put a single 1 in these, so that takes care of one of them. That means I need a 1 in one of these two. We can say the same exact thing about 2s. So we can't fit anything else in here, only 1s and 2s. Now we just figured that out through other means as well, because we got this 4 5 6 triple, which gives us the 3, which would give us the 1 2. But I think it's fun to notice that. All right, and that places the 3 here as well. And this is a 1 2 6 triple, so these aren't 6. 4 5 pair gives us the 6 here. This is not a 6. Okay, thinking about these two rows was very fruitful. Something I want to point out is that this is a 4 5 pair, so anything seen by these cells, which is just this cell and this cell, can't be 4 5. So this can't be 3, 4, or 5. So this is from 1, 2, 6 only. I don't think we can put a 1 in a 14 cage. I think 2 is too small as well. I know that there's this 3. Let me place it. We're probably looking at that. We doot in the corner. All right, back to this. So the maximum, let's think about it this way. The maximum these two can add to is 5 plus 6, which is 11. To get to 14, we need at least 3 more. So this can't be 1 or 2. So this is now a 6 because it can't be the 4 5, right? This is a 4 5 pair. However, the 4 5 resolves, this cell can't be 4 or 5. So this is not a 6. That places the 6 here. Good progress. 6 in this region is here now because we had this 6 looking in. This region needs a 6, which can only go there. This region is going to need a 6, which can only go there, and we're done. With 6s, not done with the puzzle. Let's think about what these add to now. We have 6 already, so 14 minus 6 is 8. And we can't do 2, 6. We have to do 3, 5, and this 3 tells us the order. Nice. And so now these are 1, 2, and 4. Don't think I can do much with that. Well, one thing I can do is see that 4's claim in this column. So 4 is in one of these two, which means it can't be here. If we had a 4 here, we'd have nowhere to put 4 in this column because these share a region. Okay. I think this 10 cage is going to have to resolve everything. So let's think about it. It doesn't have a 3 or a 6 in it. If it didn't have a 1 in it, then we would have to be 2, 3, 5. And we can't use the 3, right? So the minimum we would be is 2, 4, 5 without the 3. And without the 1 and the 3, we'd be 2, 4, 5. And that is 9 plus 2. That's 11. So that's too big. So we do need to use a 1. So there's going to be a 1 in here somewhere. We can repeat that trick with 1s, but let's see what else goes in here. Now the remaining digits add to 9. We can't do 2, 7, and we can't do 3, 6, so it's going to be 1, 4, 5. Perfect. And that leaves the 2 behind down here. This is 1, 4, 5 for the column. We have a 1, 4, 5 triple here. So this is going to be the digit that's missing. It's the 2. And then also notice that we have the same thing claiming in the column. We're 1s in one of these, so this can't be a 1. Now in this column, this is the only place for 1. So this is 4, 5 for the region, also for the row. So we have a 4, 5 pair here. 1 and 2 are left, so this is 1 or 2. But remember our trick from earlier. There's a 1 somewhere in here, and there's a 1 somewhere in here. That's 2 1s. That's all the 1s we get for these 2 rows. So this can't be another 1. This has to be a 2. And that resolves all of these. Nice. We get the 4, 1, and 2 here as well. We get the 1 here, the 5, and the 4. I think we're finishing up. This is 4 and 5. Up here we get the 5, which resolves all of these 4 5s. See, this did become a 4 5 pair because it is a region. And you can see that that's why this couldn't be 4 or 5, in case that's unclear. The 2 digits remaining are 1 and 4. That's 4, that's 1, and we're done. Very nice. Okay. That was a really neat puzzle, Rockrat. I enjoyed how that flowed. Lots of interesting logic with how the cages got restricted. Interesting irregular logic. Interesting stuff with like this 4 5 pair. A lot of interesting stuff in these rows and these rows in terms of how these cages used up all of certain digits for these rows. I enjoyed that as well. Cool. Well, I hope you enjoyed it. Let me know how you did. And if you did enjoy it, then why not leave a like, subscribe, and a kind comment below.